okay? That leads us into this idea of how do we diagram out or how do we identify the forces that we deal with in our world, okay? To do that, we use something called vectors. Vectors are basically an arrow system that we use to point the direction that we are seeing forces and the magnitude of those. So the length of the arrow plays a role here, okay? So for example, on the screen here, we see 3 different arrows, a blue arrow, a green arrow, and a red arrow. All 3 of these arrows would be a vector. They're saying that there's a force being pushed from right to left in this direction. Of these 3, we would know that the green arrow represents the most powerful force because it's the longest arrow. The blue would be the weakest force, and the red would be in the middle someplace. Okay? They're all pushing to the left, but the green one would create the biggest acceleration because it's the biggest amount of force. The blue would create the least amount of acceleration here. Okay? In this image down here, we see that a lot of times forces can cancel each other out. So we have the force of friction pulling this direction. We have a force being applied on the box in this direction. We have something called the normal force, which we'll get into later, going up, and gravity going down. So if all these arrows are equal in length in opposite direction, that box won't move. Or the box will keep moving at the same speed. Okay? So sometimes students think, hey, this means it's not moving at all. No, it means it's not accelerating. Okay? So it could be moving at 1 meter per second, or 0 meters per second, or negative 10 meters per second, but it won't be accelerating if all these lines are equal. Okay? Here's another example of 2 force vectors. In this case, our yellow going up and our pinkish, maroon, fuchsia, whatever you want to call it, not maroon, going down, they are in opposite direction but equal in length. So these would generate no net force. So again, kind of like we talked about over here, we have opposite forces, opposite vectors, they would be canceling each other out in terms of drawing this up, okay? Here we have 2 forces in the same direction to the right with the same amount of magnitude. So both of these forces would be pushing to the right, creating an acceleration to the right. Here we have crossing or perpendicular forces. So the white arrow is perpendicular to the gray arrow. So in this case, the white arrow would have no bearing on the gray arrow. They wouldn't affect each other, okay? So only forces that are in the same direction can affect other forces. So in this case, the white arrow would have no bearing on what's going on to the gray arrow. The force applied would not affect gravity. Gravity would not affect the force applied because they are perpendicular to each other. Okay, and we'll work more of this stuff out, but we're just kind of introducing it here in this slide as these different concepts of same direction but off different magnitudes, opposite direction, same magnitude, same direction, same magnitude, and what's it mean to be perpendicular? So perpendicular means that this force would not affect that force. Okay, we're going to go into the different types of forces that we had to deal with in our class. Okay. So there's several different forces, and we're going to break each one of them down. Now, the first force is weight, okay? That might be kind of new to you. It's like, wait, weight is a force? Yeah, it actually is. Remember, weight is measured in newtons, and newtons are forces, okay? So weight is the force of gravity, okay? Like a little Wile E. Coyote over here. We will symbolize weight as force G, meaning this is the force to remind us it is a force of gravity, okay? We're going to do that. We will use this a lot because one of the most dominant forces in our world that we deal with on our planet is gravity. Okay, so gravity is always pulling us down. It's always present. We can't get away from gravity in most cases. A couple we can. We'll do that later in the year. But for the most part, gravity is a force that we need to deal with at all times because it's always pulling us downwards. Okay, so a force of gravity typically is a negative force also. It's actually typically going to be a negative sign. So you might want to make a note of that here, that gravity or weight typically is negative force because it's usually pulling us downwards. Okay. We have applied forces. Okay, so applied force is any force that comes from an outside source. Okay, you push a box, you pull a wagon, you lift a bag, you use your muscles and push off on ice skates, okay? You use your fingers to press the keys of a piano. You use your arms to swing a racket and hit a tennis ball, okay? So those are all applied forces. It's some way that we're creating the force in the scenario, okay? Think athletics. it's any time that we make a ball move or move around or our own bodies move, we're applying forces, okay? So it could be a sprinter coming out of the blocks. It can be a volleyball player, jumping to do a block, okay? It could be a mountain biker pushing hard on the pedals, okay? It can be a runner, launching off the trail, and that kind of stuff can be considered an applied force, okay? These tend to be left and right in direction. They can be up and down too, but they tend to be left and right also. Okay, the symbolism we're going to use that is F sub A. Okay, so F is always going to be force. The little subscript is going to tell you what kind it is. So we have a gravitational and we have applied. Okay, those are our two to start with. Then we get to the normal force. Now the normal force is probably the one you're like, what is normal force? Okay, so normal force is this force that exists, okay, anytime an object contacts a surface and that surface is holding it up, okay? So imagine, like right now, I have my laptop sitting on top of a little stand here, and this laptop isn't falling through the stand, it's sitting there and it's not moving, okay? Or you sit down on a chair, or you put your plate on a table, or a car rolls down the road, or you walk across the floor of a 10-story building. Well, the reason why is you walk across, the 5th floor of that building, you're stepping and gravity is pulling you down. So you have gravitational force pulling you down, but that floor is stopping you from moving. So that floor is creating what we call normal force. It's an upward force, okay? Now, anytime we have an object that's sitting on any surface, okay, it generates normal force, all right? It's always perpendicular to the surface, which means it's not always perpendicular or opposite of gravity, okay? If we have a horizontal surface, yes, okay? So your normal force, F sub n for normal, will equal with the opposite sign. Remember, this is going to be negative, this will be positive, so I would write that in. Put a little negative sign here, a little positive sign here, okay? It's going to be equal but opposite of gravitational force as long as we have a horizontal surface, okay? So we can say that the normal force is a positive Fg. Keep in mind, anytime we have an angled surface, okay, and we'll get to some scenarios where we have some angled surface later on, the normal force is perpendicular to the surface, not necessarily gravity, okay? So for now, let's kind of keep in mind that yes, normal force is always a force that's perpendicular to our surface. If we have a horizontal surface, which most of the time we will, okay, then we can set these equal to each other but opposite. However, anytime we have angles or sloping things, ramps, slides, those kind of things, handicapped walkways, staircases, those kind of things, we end up having the normal force pulling off at an angle because it's perpendicular to the slope of your surface, and it won't be opposite of your gravitational force instead, okay? So that's our normal force. All right, last but not least, friction, okay? In all cases, we have friction. So we have this idea that if we're going to apply a force, there's going to be some sort of force that opposes that motion, okay? So any force that opposes motion, that tries to stop the motion from happening, we call friction, okay? Now, there's different types of friction. There's rolling friction, there's sliding friction, there's static friction, there's moving friction. There's air resistance. Sometimes we call that drag. Okay, so air resistance is a type of friction, but they're all the same basic type of force. They're all friction force, okay? So friction forces always oppose the motion, okay? They will have an opposite sign to them, okay? So whatever our motion is, they're going to be the opposite of that sign. So if our motion is to the left and left is positive, we're going to make friction negative, okay? If you're pushing a lawnmower and you're pushing it in this direction, so the applied force is to the left, the force of friction is to the right, okay? When you're driving a car, the car will be driving to the left. However, you're going to have rolling friction on your wheels and air resistance and probably some friction of the engine itself, not against it. So you're going to have multiple places where there's friction going against that driving force, okay? Do you want to make note that there is a special type called air resistance, okay? And that's just friction of the air as we push past something, okay? All right, what we're gonna do in our next lecture or next session is start to combine these forces together and find the result of that, okay? So we're gonna end the video lesson here, but we wanna talk about this idea that if we know all these different forces, okay, we can start combining them together and doing what we call as a force diagram that can start to map out, well, what happens if I have this much applied force, this much friction, this much gravity, this much normal force, what's going to happen to the object? Or start to explain why the object is going to accelerate, or it's going to speed up or slow down or not move, and those kind of things, okay? So we do need to combine these forces together. We can add them together, and the sum of them will be our net force, okay? If we go all the way back to Newton's first law, we said that an object is going to keep basically doing its own thing. It's going to stay at rest or stay in movement until we apply a net force, okay? So our job here is going to be, how do we figure out what that net force is, okay? So we have all these different forces we talked about: normal force, gravity, applied force, friction. If we sum them all up, we should be able to solve for a net force. And that will tell us what happens to our object. Okay, so that will tell us how do we stop it from moving, speed it up, slow it down, and those kind of things. Okay, and then what's that change in motion called? Okay, little spoiler, it's acceleration. Yeah, just acceleration. So if you have a change in motion, it's an acceleration. Okay, all right, guys, I'm gonna wrap it up here, and we'll go from there. Thank you.